Hello friends, I welcome you in my YouTube channel. I am Dr. Sirajul Faizi. So today in this video I am going to discuss on spectroscopy, especially spectrophotometry, UV visible spectrometer. So friends, you know the meaning of spectroscopy. Spectroscopy is the branch of science dealing the study of interaction of electromagnetic radiations with matter. The second definition is it is the measurement of electromagnetic radiations absorbed or emitted when molecule or ions or atom of a sample move from one energy state to another energy state. The spectroscopy is the most powerful tool available for the study of atomic and molecular structure and is used in the analysis of a wide range of samples. Now, what is the principle of spectroscopy? The principle is based on the measurement of a spectrum of sample containing atom or molecule. A spectrum is a graph of intensity of absorbed or emitted radiations by sample versus frequency or wavelength. The spectrometer is an instrument designed to measure the spectrum of compound. So there are two types: absorption spectroscopy and analytical technique, which concern with the measurement of absorptions and of electromagnetic radiations, UV and visible spectroscopy, IR spectroscopy. Emission spectroscopy and analytical technique in which emission of particles or radiation is dispersed according to the some properties of the emission and amount of dispersion is measured. Example, mass spectroscopy. Now, electromagnetic radiations. Electromagnetic radiation consists of discrete packets of energy which are called photons. The photons consist of an oscillating electric field and an oscillating magnetic field which are perpendicular to each other. Now, wavelength. It is the distance between two successive maxima on an electromagnetic wave. Units are meter, centimeter, millimeter, nanometer and micrometer. Frequency, number of wavelength unit passed through a given point in unit cell is called frequency. It is denoted by nu and unit arc cycle per second, Hertz. Wave numbers 1 by wavelength as the number of waves per centimeter in Hawking. Velocity, it is the product of wavelength and frequency and is equal to the velocity of the wave in area. V is equal to n lambda. The relationship between wavelength and frequency can be written as C is equal to nu lambda. As photon is subjected to energy, so E is equal to h nu Sc by lambda. Now, interaction of EMR with matter. Electronic energy level. At room temperature, molecules are in the lowest energy level, E0, when the molecules absorb UV visible light from EMR. One of the outermost bond, lone pair of electron is promoted to higher energy state such as E1, E2, En is called an electronic transition and difference is del E is equal to h nu En minus E0. So vibrational energy level, these are less energy level than the electronic energy level. The spacing between energy level are relatively small. When higher radiation is absorbed, molecules are excited from one vibration level to another. It vibrates with higher amplitudes. Now, rotational energy levels. These energy levels are quantized and discrete. The spacing between energy levels are even smaller than vibrational energy levels. E rotational, E vibrational and E electronic. The electronic transition, sigma sigma star transition. An electron is a bonding cis orbital excited to the corresponding antibonding orbital and absorbed with the saturated compound. The energy required is large. For example, methane has only CH bonds and can only undergo sigma sigma star transition, shows an absorbance maximum at 125 nanometer. Absorption maximum due to sigma sigma transition are not seen in typical UV visible spectra, but in UV regions you can see. N2 sigma star transition, saturated compound containing atom with lone pairs, non-bonding electrons like oxygen, nitrogen, sulfur and halogens are capable of N2 sigma star transition. These transitions usually need less energy than N2 sigma star transitions. They can be initiated by light whose wavelength is anywhere 150 to 250 nanometer. The number of organic functional groups with N2 sigma star peak in the UV region is small. Now, pi star transition, pi electron in bonding orbital is excited to the corresponding antibonding orbital pi star and absorbed in conjugated compound. Compounds containing multiple bonds like alkenes, alkynes, carbonyl, nitrile, aromatic compounds etc. undergo pi to pi star transitions. Alkane generally absorbed in the region. Now, N2 pi star transition. An electron from non-bonding orbital is prompted to anti-bonding pi star orbital and requires lower energy. Compounds containing double bonds involving heteroatoms, carbon monoxide or ketone, and cyanonitrile, NO undergo such transition. N2 pi star transition require minimum energy and show absorption at the longer wavelength around 300. So, term used in UV visible spectroscopy, chromophore. The part of molecule responsible for imparting color are called as chromophore. The functional group containing multiple bonds capable of absorbing radiation above 200 nanometer due to N2 pi star and pi star transition. Oxochrome, the functional group attached to a chromophore which modify the ability of a chromophore to absorb light, altering the wavelength or intensity of absorptions, or functional group with non-bonding electron that does not absorb radiation near UV regions but when attached to a chromophore alter the wavelength and intensity of the absorption. Example, benzene 225 nanometer, phenol 270 nanometer, and aniline 280 nanometer. Now friend, absorptions and intensity shift. You can see the hypochromic shift, hyperchromic shift, red shift and blue shift. Now, UV visible spectroscopy theory involved when beam of light falls on a solution or homogeneous media, a portion of light is reflected from the surface of the media, a portion is absorbed within the medium and remaining is transmitted through the medium. Thus, if I0 is the intensity of radiation falling on the media, IR is the amount of the radiation reflected, IA is the amount of radiation absorbed, and IT is the amount of radiation transmitted. Thus, I0 is equal to IR, IA and IT. So, law involved Beer's law, Lambert's law, Beer-Lambert's law. When a beam of monochromatic light is passed through a homogeneous absorbing medium, the rate of decrease of intensity of radiation with increase in the concentration of absorbing species is directly proportional to intensity of the incident light, di by dc ki minus di by I kdc. On integrations of above equation, ln I is equal to kc plus b, b integration constant. When concentration 0, then there is no absorbance, hence I is equal to I0. Therefore, substituting in equation minus ln I k into 0 plus b minus ln I is equal to b. Now, substituting the value of b in equation ln I is equal to kc, and then you will get I is equal to I0 exponential minus kc. So, Lambert's law, when a beam of monochromatic light is passed through a homogeneous absorbing medium, the rate of decrease of intensity addition with thickness of absorbing medium is directly proportional to the intensity of incident light. You can see the derived formula. So, now combining equation 2, after combining you will get the A is equal to epsilon Ct. So, here absorbance, molar extension coefficient, concentration of sample path length in centimeter, normally 10 mm or 1 centimeter. 10 mm or 1 centimeter. Epsilon can be expressed as follows. Now instrumentation. Source of radiation, collimating system, monochromator system, sample holder, detector, amplifier and readout device. You can see the simple grid. Source of radiation, requirement of an ideal source, tungsten halogen lamp. Demerit emits the major portions of radiation in the IR region of the spectrum, hydrogen discharge lamp. xenon discharge lamp, mercury discharge lamp, collimating system, mirror, slit, monochromators, filters, absorption filter, demeritless structure, band pass, interference filter, visble, gratings, mechanism, transmittance, and advantages, sample holder or pivot. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. You can see also detector requirement for an ideal detector, barrier layer. You can see here thin layer of silver, phototube and photoemissive tube, photomultiplier tube. You can see readout device, single beam spectrophotometer. Light from source is carried out through lens. After passing through the solution, the light strikes the surface of detector. So double beam UV spectrum. Double beam instrument is the one which two beams are formed in their space by U-shaped mirror called beam splitter or beam chopper. Chopper is the device consisting of circular disc. Single beam, double beam, firstly rapid scanning over wide lambda range. Disadvantage of single and double spectrophotometer. So this is the comparison. Application of visible, qualitative and quantum analysis, detection of impurities, structure elucidation. These are applications. Choice of solvent. Woodward Pfizer rules. I already discussed. Thank you. If you like this video, then subscribe my channel. Thanks for watching.